Hey, Y Combinator. My name is Ollie, and I'm a third year at the University of Virginia studying my own custom major in applied artificial intelligence. Today, I have for you guys the most technically impressive thing that I've built. I will preface this by saying I don't think it's the coolest thing that I've built, as I feel like I've worked on stuff that's a lot more like consumer-facing value and product-centered. But this is really cool nonetheless, and I am super proud of it, so I'd love to show you guys. And so I have a stitching algorithm that I put together. It says 54 minutes ago, but I just added this to a GitHub repo. I worked on it for quite a while. But really, the crux of this is a core problem in computer vision called image stitching. And if you're not familiar, image stitching is just when you have a lot of different images of the same thing. So, for example, here we have this beautiful landscape, and I've got a bunch of different pictures that are oriented differently and sort of highlight different parts of this landscape. And I want to stitch them together, like the name sort of says. But yeah, so I have my implementation of an image stitcher. Oh, sorry about that. This is sort of how it works. You start off by detecting blobs in the two images that you have. And so for the sake of this example, I'll show you I have this image of this hill and this other image of this hill, and I want to stitch them together. So the first thing I would do is detect blobs. And blobs are really just these sort of condensed activations of pixels in an image. So I might have a blob that's like right here, which is like a group of those gray pixels together. I might have like a blob here for this group of the shadow over here. And so you run a blob detector on both of the images that you have. And then using the blobs that you identify in both images, you can match them together and then use those matches to calculate how you should shift the one image to match another one or sort of line up with it. So that's a high level overview, but if we go into the crux of this algorithm, I start off with my blob detection, and I can go into this and show you guys how that works. It uses something called difference of Gaussians, which is basically just you use a Laplacian scale space. So you basically iterate over different scales of the image. You start with a really zoomed in scale of the image to identify small blobs and then work your way up to get to the bigger ones. And you apply this Gaussian filter to it. And so a Gaussian filter is just calculating the changes in the density of the pixels. And so for pixels that are condensed together, you'll basically get these activations as part of the filter. But this is where I iterate over the scale space. I generate the filter, and then I look for all of the activations. Then I get rid of the overlaps. And so like if it identifies two blobs that are really close together, it'll sort of calculate which one should be which. And so it'll get rid of the ones that shouldn't be there. And then I do this distance-based filtering. For the sake of time, I won't really get into it. But then I just do some final checks, and then I return the highest activations of the blobs that I detected. So once you get the blobs in both of your images, you compute this sift. And a sift function is really just calculating what the features of the image are. And so like once you pass in all of the blobs, you use this sift function to identify sort of the most relevant ones, and then you can run this matches algorithm. So these two things work together. Sift is really just trying to find the matches between the two images. And so you use this ratio called the Lowe's ratio. It's from a research paper that David Lowe wrote. And it's supposed to be 0.8, but I reduced it to make it a little bit better for my example. But you use this threshold to identify which matches on the two images are most similar. And then once you have the most similar matches in the blobs, then you run this Ransac algorithm. And Ransac is like a really well-known algorithm in computer vision, which is basically just given the two different images and their matches, identify the transformation that you need to make. So like, it calculates a matrix of how the first image needs to be transformed in order to match with the second one. And so this is just my iteration of Ransac, where I go over for an arbitrary number of iterations. In this case, it's 1,000. You calculate what the transformation between just a couple of random matches are, and then you can sort of shape together this matrix after iterating over all the different combinations of matches. But I've ran an example for you guys here, and this is what it looks like. And so in my two images, these little black circles are the blobs, and these lines are the detections of the matches between them. So we've got a blob here that corresponds to this one to this one. So you can see it did a fairly good job of identifying the two matching features as like this hill corresponds to this hill. So we see this general match being made here. And then I can see what the actual stitch looks like, just like this. And so it lays the two images together by calculating what that transformation should be. And I think I printed out here, actually. Yep, so it calculates, this is the matrix, that's literally how this image is being transformed to match. But yeah, this is my image stitcher, and I hope you enjoy. Thank you for letting me show you.